Hello everyone, welcome to exercise 15.2 and I'll be covering question number 5, 6, 7 and 8. These are all the informations of the book, the publication and the author of the book I'll be covering, and this is the cover for the book. And in the future videos, I won't be writing all of this in this whiteboard, but I'll be writing it in the description below. Now, let's start with question number 5. 1 plus x squared dy by dx is equals to 1. We have to separate the x functions and y functions, or the x family and the y family separately, where dx and dy are the head of the family. So here dy equals to, move the dx up here, this becomes dx, and this 1 plus x squared goes below, and we can integrate both sides. And here integration of dx is y, and integration of dx by 1 plus x squared. Well, this is simply the inverse tangent of x, and don't forget our constant plus c, and that is the required answer. Now, for question number C. dy by dx is equals to e to the power x plus 1 by y. So again, let's separate the y and x's. So y dy is equals to e to the power x plus 1 dx, and integrate both sides. This becomes y squared by 2. This becomes, integration of e to the power x is e to the power x. Integration of 1 is x. Don't forget the constant c. And finally, we get y squared equals to 2 e to the power x plus 2x plus, 2 into c is just another constant. Let's just write it as k. Or if you want, you can write it as c1 and finish it off with c to get the exact answer in the book. Now, let's move on to the 7th question. dy by dx plus 4x is equals to 2 e to the power 2x. Now, again, we have to separate the dy's and dx's. So dy is equals to, first, let's move it right here. So this becomes 2 e to the power 2x minus 4x, and move the dx over there. So this becomes dx. Now, if you want, you can take 2 common, but it will be nicer if you actually don't take 2 common. So, or, integrate both sides. You get y equals to, this is integrating this minus integrating 4x dx. Now, integration of 2 e to the power 2x, the 2 goes outside. This becomes e to the power 2x by the coefficient of x, which is 2, minus the integration of 4x, which is just 4x squared by 2, 2 and 4 cancels, remaining 2, and our constant c. So therefore we get y equals to e to the power 2x minus 2x squared plus c. Now, let's move on to the 8th question, which will be kind of tough, because not only will you require calculus knowledge, you will also require trigonometric knowledge. So, for 8th question. Now, for the first step, I'll just move this term to the right hand side, minus this part, and now let's separate the y's and x's. So this becomes dy root 1 minus y squared equals to minus root 1 minus x squared dx by root 1 minus x squared. And now let's integrate both sides, and I'll put the minus outside and integrate this part. Now, the integration of dx by root 1 minus x squared is, sine inverse x, and this is of course sine inverse y. This becomes minus, and don't forget the constant, which I'll write c1. Now let's move this minus to the right hand side. This becomes sine inverse x plus sine inverse y is equals to c1. Now, I'll be explaining this part later, but for now, this is sine inverse of x root 1 minus y square plus y root 1 minus x square equals to, well, we can write this constant as the sine inverse of another constant, let's say c, because the trigonometric, inverse trigonometric, exponential logarithm function of a constant is just another constant. Now, the sine inverse cancels, therefore we get x root 1 minus y square plus y root 1 minus x square equals to c. So, as I said earlier, I'll be explaining this part right here, or proving that part. So, sine inverse x plus sine inverse y is equals to sine inverse of x root 1 minus y square plus y root 1 minus x square. So, first let sine inverse x is equals to a, such that you get x equals to sine a. Similarly, let sine inverse y is equals to b and y equals to sine b. Now, this kind of looks like our sine a cos b plus cos a sine b. So, let's write sine a plus b. Let's use what we know. So, we know that this is equals to sine a cos b plus cos a sine b. Now, let's talk about cos a and sine b. So, from here we have x equals to sine a. Now, what is cos a in terms of sine a? Well, it is root 1 minus sine square a, but sine a is x, so cos a is equals to root 1 minus x square. So that means sine a plus b is equals to sine a is our x, cos b becomes root 1 minus y square plus cos a is our y, sorry, it's root 1 minus x square, and sine b is y. And now we can sine inverse over there. This becomes a plus b is equals to sine inverse whole of this, but we can write a plus b as sine inverse x plus sine inverse y. This becomes x root 1 minus y square plus y root 1 minus x square. And this is the proof of this, and I'll be covering the next 4 questions in the next video. If you learned something new, please like and subscribe. Thank you.